Digital modulation. So in that digital modulation, there's a pulse code modulation is there. So what is pulse code modulation? So pulse code modulation, it's analog information into binary sequence. That means analog signal converted into binary sequence. The binary sequence we know that is 1 or 0. So pulse code modulation will resemble the binary equation. You see a sine wave, that's the input. The following figure is shown the pulse code modulation with respect to the value of sine wave. The sine wave shown that, and pulse code modulation output also there. You see that. So instead of pulse train, pulse code produce series number of digits. Previously it's a train pulse. Now it's a number, series number of digits is produced. So instead of pulse train, previously the PPM, PWM, PIM, there is a pulse train is produced. Here the number or digits is produced. That means zeros or one is produced for analog signal. So that is called as pulse code modulation. So the binary code is representing that is approximately amplitude of the signal of the input signal. The pulse code modulation is a message signal. It's represented by sequence of coded pulse. So basic element of PCM. What are the basic element of PCM? So that that we will see from this diagram. So this is PCM black diagram. So analog message signal and low pass filter and sampler, quantizer, encoder, PCM output given to the channel, and regenerative repeaters and regenerative that channel having there are continue regenerative repeaters and regeneration circuits, decoder, and reconstruction filter and destinations. So the receiver section. So in pulse code modulation, if you that analog message signal sine wave even to pulse code modulation, the pulse code output is you will be get it zeros and ones. It's a number form. So low pass filter, so it will be eliminate high frequency component, and sampler after eliminating high frequency component. Why we are using low pass filter in pulse code modulation? That is we saw in the starting of fifth unit. That means now we are seeing fifth unit. The starting we saw, you know, we having aliasing effect. Once the sampling frequency is it is not a twice, that means is less than twice the highest frequency means, then you will be getting that signal getting overlapped, so the signal might be lost. So avoiding that is we can call as a aliasing effect. So avoid this aliasing effect, we place anti-aliasing low pass filter. That is a filter shown here, low pass filter. So low pass filter, sampler, quantizer, and encoder. So sampler will be take the sample of the input system. Then quantizer, so quantize the signal that is approximately equal to the input signal. What is sampling? Sampling is a piece of data taking from the whole data processing. Then encoding, finally, then you will be getting PCM output section once that will be sent to a channel. So there is a regenerative repeaters. So regenerative repeaters that will be strengthen the channel, and finally you will be get the decoder. So encoder, decoder, it is used for hacking, avoid hacking. That's why we are using encoder and decoder. Then reconstruction filter. So reconstruction filter, it is easy to reconstruct why the signal might be that sampling frequency is greater than twice the frequency. So then the reconstruction is easy. Then final destination, you got that original signal. So this total operation called as a pulse code modulation. So this is the operation just now we discussed. So there is a thing is shown again. Next one is multiplexing. What is multiplexing? Multiplexing is nothing but many signal into one signal, that is called as multiplexing. So this process is called analog multiplexing. So here, analog is a nature. So digital signals are in multiplexed, that is called as digital multiplexing. Where that analog multiplexing means there is an analog signal. So if you go into multiplying digital signal, that is called as digital multiplexing. The multiplexing was developed in telephony. A number of signals, there are so many number of signals combined and sent through one single cable. So there the process multiplexing we have. So the multiplexing divide a communication channel into several number. So that is allotted to each different message signal or data stream to be transferred. The device that does multiplexing can be called as a mux. The reverse process, so extracting the number of channels from one which receive the signal demultiplexing. The device which is does demultiplexing is called demux. So see, multiplexing many to one and one to many is a demultiplexing. So types of multiplexer, there are mainly two types of multiplexer, namely analog and digital. There are analog and digital further it is divided. So FDM, WDM and TDM. Following a figure will be shown the classification. What is FDM? Yeah, multiplexer, analog and digital. So under the analog we have FDM, frequency division multiplexing, wavelength division multiplexing, and digital TDM, time division multiplexing, that is divided into two, synchronous TDM or synchronous TDM. So analog multiplexing technique, we know that's a nature signal. So that is involved FDM and WDM. Yeah, FDM and WDM. So frequency division multiplexing. These techniques, various frequencies combined a stream of data. No, the various frequency we have to combine and the stream of data and send them to communication medium, that is in a single signal. But actually, various frequencies are combined in a stream of data. Various frequencies to combine streams of data for sending them on a communication medium as a single signal. So this is an example for television transmitter for send a number of channel through a single cable, that is called as FDM, frequency division multiplexing. And wavelength division multiplexing. So there various frequency is combined and combined streams of data, and here you know the telecommunication they are using a light signal, light spectrum. The various light spectrum combine a stream of data and sending them on a communication medium as a single cable. That is, the cable here is optical fiber. So the optical fiber communication, we have various light signal and combining the stream of data sent to optical fiber communication. So merge wavelength, that finally the single light communication. So this is called as wavelength division multiplexing. And digital multiplexing, we have TDM, uh, time division multiplexing. So time frame divided into slats and technique used to transmit signal over a single communication. So the TDM again split it into two types, synchronous and asynchronous. So synchronous TDM, the input is connected in a frame. You know that there are n number of connections. The frames are divided into n times slots. Once the slot is allocated for each input line, in this technique, the sampling rate is common for all the signal. Hence, the same clock input is given. The mux allocate the same slot to each device at all the times. So asynchronous TDM. So asynchronous TDM, sampling rate is different in each of the signal. Common clock is not required. Synchronous, asynchronous. Synchronous is a common clock is needed because of sending data in TDM. Asynchronous, there is no common clock is needed. So the slot is allotted to another device unlike synchronous. The time this type of TDM is used on asynchronous transfer mode network. And finally, demultiplexer. It's a reverse process of multiplexing. You know, many signal converted into one single line, single cable, a single signal that will be sent to a single cable that is called as multiplexer. Demultiplexer is the opposite, reverse reaction. Then single line converted into many signal that is demultiplexing. So demultiplexing is mainly used for serial to parallel converter. The so the regular counter attached to the control output of the demultiplexer. So the both multiplexer and demultiplexer is a very important role played in communication system, the transmitter and receiver sections. Thank you. So thank you. The unit then the subject is over. Thank you.